I think you can hear me now. Welcome back. We're on to PS Bhimbra. We've been doing this PS Bhimbra questions, beautiful questions. PS Bhimbra questions. We're at part 14. This is the last part. The complete playlist has given in this video description itself. Complete playlist. Right now, we're at part 14. It's the last part. DC machines last part. Okay. So in every session, we'll try to cover 10 questions. So now we are covering the leftover 9 questions. Okay, let's get started with today's session. Today's session is really going to be interesting because you're going to learn something more, and the things what you all learned already, you may have to enhance your vision beyond what you know. Okay, so this session is going to help you to think beyond what you learn. Okay, let's get started with the first question. Okay, yep, here's the first question. I think we have seen already these questions, this kind of a question regarding amplidyne in the previous session itself. Try this. I think it's tough for regular people to try. Okay, so let me explain this question. In the previous sessions about the power amplification. Power amplification is possible for metadynes. We discussed about that. Amplidyne is also one of the type of metadyne. Okay, what are these amplidyne, metadyne? There are other special generators. They all come under a category of cross field generators. They are DC generators, but their structure is a little different. Okay, they're called cross field generator. They are the DC generators, but a little different. We're going to see those differences also in this session. Okay, if there is a question at any point of time, you can just give it in the comment. Okay, if you want to learn more, be it a free course or a paid course, you can reach us on WhatsApp. You can check the link in the description itself. Okay, yeah. Now coming to these cross field generators, be it metadyne or amplidyne, they are structurally a little different. Okay, we'll see that. Now it is said the output voltage is 100 volts when it is rotating at 1000 rpm. When it is rotating at 1000 rpm, the voltage is 100 volts. If its armature is now driven at 2000 rpm, means speed has doubled and has increased 2 times, then what is its output voltage? What is its output voltage? That's the question. So if you see, in case of a regular DC generators, if you take this as speed, if you take this as induced EMF, okay, induced EMF, generated EMF, or let's take it as a terminal voltage, whatever. If you take this, can you just tell me what will be the curve here? What will be the plot here between EG versus speed, not IF? Remember, I'm not talking about IF, I'm talking about speed. Just tell me, everyone, just tell me, what is this? What is going to be this? Yeah, I'm expecting this answer. This is very easy. This basic question. EG versus speed. Is it linearly increasing or linearly increasing at saturation? With saturation, without saturation, what is that? What is that? Only we got one answer, which is B. B has popped up here. Okay, the pop-up is so clear, not so clear, I think. Check. Any other? Only B. Only B. Okay. So for the answer, I'm talking about this curve. It is, for normal case, it is linear. For normal case, it is linearly increasing. For a normal case, it is linearly increasing. For normal DC generator. Careful with this, guys. Careful with this. This is very important. I told you you're going to learn something new in this session as well. Okay, linearly increasing like this if it's a normal generator. If the speed is negative speed, this would have gone negative like this. Induced EMF will be negative. if it is a normal generator. But if it's a cross field generator, the speed versus induced EMF characteristics will be like this. And for negative speeds, it will be like this. Means induced EMF is proportional to speed square. Now answer this question. Pravinji, if it is a regular generator, your relation is right. Induced EMF is proportional to N. If it is a regular, this is right. But for this case, you will have to use this, not this. Not this. Now tell me what is answer. I think now it's pretty much straightforward. As I said, the relation is square times. Speed has increased twice. EMF induced will increase 4 times. Means answer will be option C. Option C. I hope it's clear. Let's go to the next question. We're moving to the next question. Yeah, here you go. Hi. Vinay is back again with 1,000 highs. Hi, Vinay. Answer this. I think with the previous question analysis, you will not do mistake here now. You will not do mistake with this question because previous question analysis is pretty much clear. Then you should not be doing a mistake when answering this question. Guys, I don't know whether you're getting ready for transco and or not. Transcos and all. Get ready, get ready. Telangana people. News might come very soon. Get ready. When and all, don't worry about all those. Be a warrior. Okay, now let me answer this question. The polarity of output voltage in a cross-field generator can be altered by. We have seen just now, when you change the speed, positive speed or negative speed, induced EMF is always positive. Just in the previous case, we have seen the curve, where it is the speed is positive or negative, EMF induced is always positive. So, reversing direction of rotation will not work. Direction of rotation, this is not going to work. So, option A, option B is wrong. Reversing direction of field is the only way. Okay, because rotation will not influence in the direction of induced EMF. The only thing which will influence is field current. Field current direction when you change, it will change the induced EMF. Okay, now with the help of next question, I think you're gonna learn something more about a metadine structure. Okay, let's see the next question. Yeah, look at this question. Look at this question. The question says, let me explain here. It is tricky one. Okay, it is tricky one. In a two-pole cross-field generator. Cross-field generator means just now we're talking about amplidyne or metadine, anything. Okay, so it is about special one, not regular DC generator. What it says? There are 4 pole projections. Can this be true? It is said explicitly 2-pole machine. So in 2-pole machine, do you think there are 4 projections of pole? If you just imagine the DC machine construction, 2-pole machine, how many pole projections will be there? 2-pole machine, 2 pole projections. 5-pole machine, no odd number, even number. If it's a 6-pole machine, 6 pole projections will be there. But in case of a cross field, it is absolutely true. For 2-pole machine, it's not 2 pole projections. It is 4 pole projections. Absolutely right. So wherever you see option 2 is there, that cannot be the answer. Now, how is it possible, sir? Let's see that to understand this point, you have to know what is the structure of this cross-field generator. Cross-field generator, it appears like this is a stator where field is stationary and armature is rotating. Now if you see, poles usually, pole winding will be there here and here to the one projection. Here if it is cross, here it will be dot. Something like this will be there. Okay, like this, winding will be here like this. But in case of a cross field machine, winding is, this is dot and this is dot. I mean, it can be cross also, any direction. Here, no winding. And its corresponding opposite is here. It is cross. It is cross. So this will form one pole. This will form another pole. Of course, it will not form pole. It will not form poles here. They will form poles when the field winding is like this. Current is going in and coming out like this. This is the d-axis. D-axis, direct axis is this. This is the d-axis, means one pole will be formed here, another pole will be formed here. So if you just see that, that pole will be something like this, of course here. And this way, like this, like this, like this. This is the direct axis and this will be the quadrature axis. So two poles are formed. But how many pole projections? 4 pole projections. Now how many interpoles will be there? Definitely every interpolar region there will be interpole. 4 interpoles. 4 interpoles. How many brushes will be there? Usually there will be 4 brushes. Usually there will be 4 brushes. Of course, 2 poles means there must be 2 brushes. And these 2 brushes will be connected to the load and these 2 brushes will be short circuited. These 2 brushes will be short circuited. These 2 will be taken out. Okay. So if they are not there, these short circuiting brushes are not there, these 2 brushes will be there. Either 2 brushes or 4 brushes. Okay. I hope it is pretty much clear. This construction is, that's why it is called as cross field generator. Now look at this. There are 4 interpoles. Yes, right. Number of brushes exactly equal to 4. You cannot say exactly equal to 4. Sometimes it may be 2, sometimes it may be 4. Yes, this is absolutely right. So according to me, 1, 3, 5 is absolutely, this is the right answer. Okay. I think once you check these 3 options itself, you'll be able to mark option A is right option. No other option is matching. Okay. So this is, I think, something about cross field generator. This diagram, what you see here, yeah, this is a cross field diagram. Okay. Now let's go to the next question. I think this question you'll be able to solve it. Options are down. Okay, forget about the options. You'll be able to match it now. Curve A, curve B, curve C. 3 curves are there and different characteristics are given. Now you try to match it. Options, forget about options. You just give the matching, proper matching and complete matching. This is something interesting really. Yeah, go for the match. It is about series motor. Take that point. It is about DC series motor. That's a key point to keep a note. I think everybody will be able to say, what is curve B? Curve B is easy to say. Curve B is easy to say. Curve B for any kind of a machine, if you have something like this curve is like this, means it is efficiency versus load. X-axis is given, y-axis is not given. So curve B is efficiency. Curve B is efficiency. Match it like this. Curve A, when you're increasing load, means series field current is increasing. Means IA is increasing, means series field current is increasing. So flux is increasing. So speed reduces. Speed is reducing. So this is a curve for speed versus load. Curve A is for speed. The curve C, it's not linearly changing. It is like this. which means we know square times change. So this must be a torque. When you see in case of a series machine, torque is, it has very good torque because torque is proportional to current square. Current is nothing but proportional to load. Simple. Simple points. So this is for curve C is for torque versus load. C is mapped to 2. C is mapped to 2. Yes, Praveen Kumar, 2 brushes are sufficient. 2 brushes are only we'll use, not 4 brushes. But 2 brushes will be short circuiting. That's how you're creating the cross field. To create a cross field, armature also gives some magnetic field. I think when you understand a cross field magnetization, you will understand about this. Short circuiting will help us in creating a field also. Okay. Anyways, that's about, that's a good question, very valid question, dear. So this mapping is over. Now let's come to this. Let's come to this. You know, he really asked a nice question, Praveenji. So for that, I think if you understand cross field, this question will be cleared automatically. Okay. Yeah. Now coming to this. Yeah, faster. It's easy one, known one for you guys. I mean, these kind of questions, if you don't answer too fast, what's the use? Huh? Because if it is a cross-field machine, you might be not knowing the concepts of cross-field machines. But now this is simple, regular machine. In a DC machine, a reactance voltage, careful here. This is a beautiful question. Most of you guys will commit a mistake in answering this question. Most of you. Let's see what is this. Is cross reactance voltage produces due to the self-inductance of the coil undergoing commutation. It is definitely true. It is definitely true. Yes, it is definitely true, you can say. Okay. Next one. It is a sum of EMF induced by self and mutual fluxes. Rather than this is more appropriate. This is talking about only due to the coil undergoing commutation. But this says not just coil under commutation, sum of all. Sum of all. So, though apparently it seems like this is correct, but this is more appropriate, so I would mark this. Careful guys. Careful guys. Because it is including all coils. Absolutely right. That's very precise and perfect to pick it up. And this reactance voltage is one of the main reasons to create the delay in the commutation. Sparking at the brushes. This is one of the prime culprits. So yes, delaying commutation is just because of, one of the reasons is because of the reactance voltage. Okay. You know, in our YouTube video itself, we have a clear understanding, clear explanation with a beautiful animation about armature reaction as well as commutation. Just check that. You're gonna love armature reaction and commutation concept without any doubt. Okay. And one more thing, I think we want to announce something great. We got some this year. We have some very interesting thing to share with you guys. We are gonna bring you. So far, we are the only institute to provide lectures in 3D animations with a clear-cut, fantastic visuals, 3D visuals. We're going to give you the lectures. We are giving the lectures. So far, we're the only one because that's what our tagline, right? PiSquare, what is the PiSquare tagline? We help in bridging the gap with a multiplied effort, and we are doing that. We are doing that so far. Now, to extend that one more level, what we are doing is our team has developed some amazing tool. It's not only we interact with those 3D objects with that technology, even you are also, our paid users are also gonna interact. Yes, you are gonna interact with those 3D animations. You're gonna see it live. That experience, we got it very short in couple of days. You're gonna see that, experience that in your mobile apps, PiSquare app. Get ready, guys. Get ready, guys. That is something really exciting. Okay, yeah, we'll get it. Can be neutralized by transformer. I think option 2, 3. Yes, option 2, 3 are correct. Okay, let's see. Few more. Can be neutralized by transformer EMF induced by interpole flux. Interpole flux. Of course, this interpole flux will neutralize this reactance voltage. That is true. That is true in a way. That is true in a way. But it's not due to transformer EMF. It is dynamically induced EMF. There is no transformer action. There is no transformer action. Okay. It is dynamically induced EMF. So this is definitely not true. Can be compensated by voltage commutation? Yes, you can compensate by voltage commutation. That's what, by using interpoles, dynamically induced EMF, not transformer. Okay, transformer action. So 2, 3, 5. Yes, option C is right. Option C is right. Okay, next question. Next question. Wow. I think this is good question, but very easy one, which you'll be able to make it. Try it out. Try it out faster. Ravi Teja is saying excited. Yes, dear. Yes, we're also excited. Thank you for all of your love. I must thank only and only, not you. You guys are enjoying the benefit. If I want to thank, I should thank my team who is sitting and thinking more than what I think about you guys. They'll always think about you. They will try to give the best. They'll try to bring the best tech for you guys. Okay, I'm thankful to my team. And you can enjoy, because that's where innovation is coming up. Yeah, I think we are the only one so far. We launched for you guys. Now we're rolling not only Sunday AI, every day, only for our paid users. Our AI will answer your questions directly. We have trained along with you guys. We trained our AI also. So they also got trained along with you to answer your questions 24/7 at any time. You can ask those questions. Okay. And we are the only one who launched. And radio to get you stay motivated, you guys, all the time, to keep you motivated all the time. We launched a radio also for everyone, not only for paid users, free or paid users. It's on the app. You can experience those. Yeah. And now it is something much beyond even my imagination. That's really great. Okay, guys. Okay, guys. A commutation characteristics of a DC machines are. So there are different commutation curves we have come across. And definitely this curve 1, which is very nice and linear, this is linear commutation. Linear commutation. Out of all of these, this is linear commutation, straight line 1. Yes. Map. You don't have to look at the options because you can map it here. C is to 1. Now resistance commutation, because of the resistance commutation, you will get within the commutation time. Resistance commutation means, tell me what? What is resistance commutation? We explained those things in the YouTube free video itself. Yes, absolutely right. Increasing the resistance of the brush simply using the carbon brush. People are asking, sir, why not copper brush? Carbon is having a little high resistance. Of course, it has a good lubricant property, but it has good resistance also, significant resistance also, which will cause a voltage drop. But it's okay for us. We want that. Because of that, yes, sparking at the brush is not happening, and proper commutation is happening. Within the commutation time itself, the reversal is happening. So it is helping us. That's what the resistance commutation. So resistance commutation is this nice curve. This is a resistance commutation. Resistance commutation is curve 2. Yes, like this. Now delayed commutation. Okay, I think diagram is not so good, but yeah, delayed commutation, actually speaking, it should end up somewhere over here. Okay, this is what, to be more precise, delayed commutation should appear like, but diagram says it is here, so I had to take a chance. So this 3 is a delayed commutation, and this is accelerated commutation. So this is this, Delayed commutation is this, like this. To be more precise, it should have happened like this, and this should have happened somewhere over here like this, like this, like this, like this. Okay. But yeah, with the shape and all, if you know the concept, you'll be able to match it. This is exactly the question what we have taken from PS Bhimbra, and which are amazing questions really. It's not just the question, it's a concept. There are beautiful concepts built on that. If you just complete this series, this playlist of PS Bhimbra DC machines, if you can answer those questions very logically, very clearly, which means that you got a good concept of whole DC machines. Yes, I guarantee. Okay, you're not gonna miss a single mark if you follow all these concepts. Just 129 questions. Right now we're at maybe 125th question. Let's go to the next question. Yeah, answer this. If you answer these questions, that's amazing. That's enough. Just like PS Bhimbra, we have CL Wadhwa also, and those explanations are crystal clearly given in our test series, online test series, power systems. Guys, this is really beautiful test series with the lowest price. I think you got, yeah, CL Wadhwa questions, 29 rupees with 7 days validity. You can just try it out. This is masterpiece. Okay. Yeah. Anyways, coming back, answer this quickly. Very easy one. Very easy one. At very conceptual one, important one in terms of exam. Yeah, go on. Give it a shot. The speed torque regime in a DC motor. It is about DC motor, and the control methods suitable for the same are given by respectively group 2 and group 1. So you need to match it. Field control methods are usually for above rated speed. Simple. Field control methods are above rated speed, above base speed, right? P is to 2. So this is gone, this is gone. And armature control is below rated speeds. Q is 1. So option B is right. Option B is right. Simple. Wow. Wow. It's a little lengthy question. But if you know the concept, not that tough to answer this question. Let's see. I think for the sake of time, let me itself explain this question. But if you want to try, take a pause, press the pause button, try it yourself. This will dig a lot of your concepts. You will definitely get stuck somewhere. Then you continue watching this video. That's going to help in that way. Okay. So meanwhile, let me take up some questions which are in the chat. Sir, AP transco notification eppudu vastundi sir? Sorry dear, he's asking when is going to be the AP transco notification. We have no clue yet. We are following it up. How many of you are, you just give it in the comment guys. How many of you are actually looking for AP transco committee? How many of our students are looking for AP transco notification actually? You just reach out to this video in the comment itself. Yes, I want AP transco. I'm looking for AP transco. Then accordingly, based on the mass, we'll see what next to be done, because vacancies posts are there and you guys are ready. So we'll have to match these two and we'll do something. We'll help you out in materializing something. Okay. Anyways, coming back to this. To conduct a load test on a DC shunt motor, okay, you want to conduct a load test on a DC shunt motor, fine, this is shunt motor, remember, it is coupled to a generator which is identical to the motor, okay, DC shunt motor is coupled to generator which is identical to motor. The fields of generator is also connected to the same supply source of motor. So we have two machines, one is a motor and which is coupled to a generator. Okay, this generator, and these two machines are shunt field machines, and this is also having some field. This shunt field generator is also having some field. Both the fields are connected to some supply like this. Okay, then how it is getting loaded? Generator. The armature of a generator is connected to load resistance. Okay, this armature is connected to a load resistance. Interesting. This is interesting. Perfect combo. Guys, don't get confused. This is not a Hopkinson test or a back-to-back test. If it is a back-to-back test, this should be connected to this itself, not to external resistance. So this is not a back-to-back test or Hopkinson test. No. So yeah. So this text, whatever is exactly given here, is depicted in this diagram. I have drawn in this diagram, so you don't have to worry about this whole text. Okay, the armature resistance is 0.02 because they are identical for both the machines. It is same 0.02 per unit. Okay, armature reaction and all neglected. So till this everything is clear. We are neglecting all the losses. Armature reaction, bucker done. With the rated voltage across the motor, okay, you're applying rated voltage here. We rated means the field is rated. Both the fields are rated. Across the motor, the load resistance across the generator is adjusted to obtain rated armature current in both motor and generator. Wow. Wow. Then the per unit load resistance. So it is asking about this is rated voltage, what should be the per unit load resistance such that if I keep that resistance value in per units, we have to find, then this both the motor and generator are actually under full load condition. Both are at full load, because if this get loaded through this resistance, motor will get loaded through this generator. So both are loaded equally. That's a fantabulous question. You can just pump the hearts for this question itself. This question itself. Okay. So first of all, one key observation if you want to make it, both fields are rated, both field currents are same, and both are having same speed. When under this specific circumstance, because they are identical, their induced EMFs are same. Their induced EMFs are same because their flux is same, their speed is same, their induced EMFs are same. That is for sure. Not the terminal voltage I'm talking about the induced EMFs will be same. Induced EMF will be same. Okay, that's the first thing you have to keep it in mind. Now, by keeping that in your mind, let's try to find out what is the induced EMF in the motor. That's what we'll call it as a back EMF. The value will be Vt minus IaRa, because I'm ignoring all other drops. So this is rated 1 per unit minus armature is load obtain rated current. Rated current they want to obtain. So this is also 1 into 0.02. This is going to be 0.98. This EB is going to be 0.98. Now we know with this concept they are having same induced EMF. The generated EMF is also EG is also equal to how much? EG is also equal to 0.98. Now what is the terminal voltage? What is the terminal voltage? What is the terminal voltage? Terminal voltage will be EG minus IaRa, EG minus 0.02, which is 0.96. This is Vt. Terminal voltage is 0.96. So if the terminal voltage is 0.96, to get rated current 1 per unit, how much should be the load resistance? It should be 0.96. It should be 0.96. Then only the current will be 1 per unit. I is equal to V by R. R is equal to V by I. Okay. I is equal to V by R. That's true. But in case of here, I want RL. So R is equal to V by I. 0.96 by 1, which is 0.96. So answer is option C. See how logically this question is designed. Very simple, but very logical. Okay. Shall we go to the next question? If you just hit that like, I'll go to the next question. Okay, let me go to the next question. Good. I think this is the last question of this series. I want everybody to participate in this question because this is the last question of this series. In this entire PS Bhimbra, we covered all questions of PS Bhimbra. You can check the playlist in the description of this video. Or every video we're adding the relevant material also. If you want to check, that's every time we'll do that. Okay. Yeah, try to answer this masterpiece. Easy one. Guys, these kind of questions you normally get confused. Okay, they are simple questions. But when there is a term per unit, usually you'll go mad and you'll get confused and you're gone. You'll end up in putting a wrong answer. They're actually very easy. Even our Bulbul ma'am has explained you. So this 100 rupees course, I think you're gonna master this traction topic. Okay, just try it out. Try it out. Okay. It says a constant power load. Okay, constant power load. Keep that point. That's a key point. It is running at rated speed and rated voltage. Rated speed and rated voltage. If the speed has to brought down, your objective is to bring the speed down to 0.25, means you want to bring the speed to 1/4. It is said it is driving constant power. We know power is equal to, what's the formula? Torque into speed. Torque into speed. So if power is constant, you're bringing down the speed, their torque will be more. Their torque will be how many times more? 4 times more. 4 times more. Because speed is 1/4, torque has to be 4 times more, then only power will be constant. That's what he's trying to say. Anyways, if this has to brought down to this, what should be the voltage? What should be the voltage? Oh my god. Means what should be the input, change in input voltage? What should be the change in input voltage so that the speed will be 1/4 by keeping this load characteristics, constant power load characteristics. So if torque is to go up by 4 times, current IA, because torque is proportional to IA square in case of a series motor, IA should increase by 2 times. 2 square is 4, torque is increased by 4 times. If IA is increased by 2 times, means the voltage has to brought down, because we know power is equal to V into I. I has increased by 2 times, so voltage has to come down by 2 times. It is 0.5. It is 0.5. Are we clear with this? Are we clear with this? Input output power is constant, means input power also must be constant, providing ignoring losses. Okay, they must be constant. Are we clear? Are we clear? Any doubt? If there is a doubt, give it in the comment. Give it in the comment. We'll try to see those questions. Okay? Or ask our AI. For everyone, all of you guys in our app, PiSquare AI will be going to be active on Sundays. For paid users in your course itself, our own AI trained information is available. You can ask anytime 24/7 your question. And what I recommend is, for us to get some more information about these, feedback. I want your feedback on AI responses. So whenever you are getting answers by AI, you should ask the questions which are related to the courses what we launched. Okay, not other courses, because we have not trained the bots with the other information. Okay, and general information also we have not trained it. Okay, so in the answer, once you get the answer, there are two buttons, thumbs up and thumbs down. You just give your feedback by giving thumbs up or thumbs down. If you're happy, if you are close enough according to your question. If you ask some random question and you're expecting good answer, that's not going to happen. That's not going to happen. Okay. When you're giving this feedback, that feedback will help us to train more or retrain our bots to meet your specific requirements. So give a proper feedback on that chat replies what you're getting. Okay. And I hope you must be and you are enjoying PiSquare Radio, which will be active 24/7 for you guys. PiSquare Radio right now it is available only in Telugu. I think this month itself we're going to launch in Hindi. All things are done. We're just picking up that good inspiration songs. If you guys know some good inspiration songs from Hindi, you just share it to us on WhatsApp. We're trying to put those in PiSquare Radio's Hindi channel as well. Okay, it's gonna come very shortly. Okay, and if you want PiSquare courses, feel free to check it out our website, download our app, check the best of electrical engineering only at PiSquare Academy, and we are there to helping in bridging the gap with multiplied effort for sure. That's the end of this session. Happy learning. Enjoy the learning in PiSquare style. Have a good time. Bye bye.